So what we're gonna see is how to first generate the markers. We're gonna see the list of markers that are generated by the system, and then how to access them. And there will be a demo at the end. So as I said before, also a part of the markers are processed by the markers database processor, but others are processed by the crop type mapping processor and the agricultural practices monitoring processor. It's what we see here. And in fact, it was designed so that so new products are generated, and these products contain the markers and the markers values. You can see that the marker database processor processes two types of markers, the L4C 1 type and the L4A 4 types of markers. We're going to see them after. And it was said already before, then the marker can be accessed via a REST API, or they can be read directly in Arrow IPC files. But let's go to the list of markers. So first, the ones that are processed by the markers database processor. So these are single date markers. So it means that they are calculated for each acquisition. And so first for each biophysical indicator, so you can see NDVI, LAI, FAPAR, FCover, and also for each Sentinel-1 products, so the amplitude and the coherence. And for all of them, the mean and the standard deviation values are calculated by Parcel. And in the case of the amplitude and the coherence, the markers are separated by polarization, so VV or VH, and by orbit. And this information is given in the marker name. Then there's a second type of markers, which is MDB2, and it's just one special marker, which is the amplitude ratio, so VV on VH. And in this case, it is separated by orbit only. And again, the mean and standard deviation are calculated by Parcel. So these are the single date markers. Then there are the markers that are processed by the L4C, and the 5 first ones are also fulfilling the markers database. So in this case, it's already the results of a time series analysis. So it's why we call them not basic markers or base markers, but practice markers. And so they are binary, so true or false, and they are evaluated for each week. And you can see the definition of them here. So the two first ones are related to the NDVI. So are there high values of NDVI, which is a sign of the presence of vegetation on the ground? Or is there a break this week in the NDVI, which is a sign of a loss of vegetation? Then there are two markers related to the backscatter ratio. So the first one is an increase of the backscatter ratio during the week compared to the week before, which is a sign also of a loss of vegetation, and high values of backscatter ratio, which is also a sign of low or no vegetation on the ground, so that the backscatter signal is strong. And then the last one concerns the coherence, and there it's looking for an increase or high values of coherence, and if it's the case, it's the sign also of low or no vegetation on the ground and stable conditions from week to week. So this is the, we can say, second family of markers which are provided by the L4C. And the last family comes from the L4A. So there are optical markers, and then the one based on the Sentinel-1 data. So we can begin with the optical ones. So there was a question. So in this case, it's the results of temporal resampling. So when you launch the L4A, so you define the period that you want to, in which you want to perform the classification. And it will use all the data in this period and then do a temporal resampling every 10 days. And this is needed for the classification because you need the same information or comparable information for all the parcels of your area. And so it's why, even if there are clouds in an area, you need an information to be able to compare between the different parcels. And so there's this temporal resampling for a period of 10 days. And the first optical main, we call them optical main, are the markers that are using the 10 meters resolution data. So you can see there are three indices, the NDVI, the NDWI, so the water index, and the brightness, and then some values directly from the bands of the Sentinel-2 data. And again, the mean and the standard deviation values are calculated by parcel every 10 days. Then the second type is the red edge markers. In this case, it is using 20 meters resolution data. And it's the values of the bands that are used. And again, the mean and the standard deviation values that are calculated by parcel. Also the same temporal resampling every 10 days. Then there are the markers from the SAR data. Here it's a bit different because you are sure to get regular data. So we don't need to do a temporal resampling, which is done here. I didn't mention it, but it is done because there are often cloudy conditions. So you don't get data on a regular basis, which is the case for the SAR data. So the first, again, family, you can say, of markers are the ones that are just calculated for each week. It's a temporal mean for each week, so a 7 days period. And it is separated, so it is calculated for the amplitude and amplitude ratio and the coherence. And it is separated by the direction of the satellite, so ascending, descending, and also by the polarization. And again, the mean and standard deviation values are calculated. Then there are specific temporal features. What I didn't mention also is that these markers were selected during the benchmarking phase, so during the development of the processor. And they are the best, they were selected because they are the best to distinguish between the different crop types. And so the second part of SAR markers are temporal statistics that are calculated, but over different periods of time. And it's not only the mean, but there are also other statistics that are calculated. So the first ones are calculated every month, and the mean and the quantile 10 values are calculated for this period. And the quantile 10 is a proxy of the minimum value. And this is done for the coherence VV and VH. Then there are markers processed for every 2 months. And there the statistics are the mean and the coefficient of variation for the amplitude and amplitude ratio. And finally, there are markers calculated for the over the whole monitoring period, and in this case, it's only the standard deviation. And again, all these values are then calculated by parcel, the mean and the standard deviation. So this is the list of markers that are calculated. They are also documented in the software user manual, and the name of them and so on. And now how to access them after they are processed. So there's a figure here on the right where you can see that, so you can see the central database with the markers, and the markers are exposed through a REST API. And so any application can read or can request the markers values through this REST API. And for example, it will be also the case in the version 3.0 of the system. So it was said also yesterday that the main evolution for the version 3 will be a new visualization of the product with visualization tab. And you will be able to, in fact, visualize the markers directly, do some temporal profiles and so on. And so this web interface will use the API to see these markers values, but you can include them in codes, in scripts, or in application that you develop. And the other way to access them, in fact, they are stored also in Arrow IPC files. And you can access them and read them directly in the system. So what are the advantages of this? For the REST API is the fact that you can do some requests for the markers, and with also filter options. And we're going to see the different options. But for example, selecting only some markers, selecting markers only for some parcels, or just in one area. We're going to see it in details. And what you get is a simple JSON response with the markers values. And about the Arrow IPC files, it was chosen instead, for example, of CSV files because they are faster to read, and they are smaller in terms of volume. They are widely supported by the different languages, and they can be indexed for faster random access. And practically, how does it work? So for the API service, you can use, so you have to define the request. And in this request, you have to define the series of information. These informations are also listed here. They are all mandatory. Yeah, and what I didn't say is that it has to be done in 2 steps. So first you can request the marker names, and then using some of these marker names, you can request the markers values. And so the first step is here in this slide. So request the list of marker names. And you can see an example here. So first you have to define the IP address of the machine where the system is installed with the right port. You have to define the site. So the site of on your system from which you want to extract the markers, the product type. So we saw that there are different product type. It's also listed here. And you have to define which type do you want, and the year of the markers that you want to extract. And when you do that, it will gives you this kind of JSON answer. So with the name of the different markers, you can see here the different biophysical indicators, the mean and the standard deviation, and then the amplitude and the coherence, which are separated by polarization and by orbit. Everything is also explained in the sum. So this is for the marker names, and then you can request the markers values. In this case, some information that you have to fill in are mandatory, and some are optional for the filtering of the data. So for the mandatory information, it's again the site, the product type, the year, which are the same than the names, but then you have to specify also the names of the markers that you want to extract, and you have to separate them by a comma. And then you have some filtering option if you want to only extract markers from a date to a date, so given a certain period of time. You can also filter by extent, so by region of interest, using the WKT format for this. And you can extract also a filter by parcel, so by given the new ID of the parcel from which you want to extract the markers. And so it looks like that when you are doing it. So in this case, selected this product type, so MDB1, and I selected only the mean NDVI and mean LAI for these two parcels, and from the 1st of June until the end of July, and you get this answer. So it listed, in fact, it lists all the dates that are possible for all the parcels, in fact, in the whole monitoring area. So you can see all the dates, and then for each parcel, you can see the marker values. Of course, it's often 0 because there is no data from this date above this parcel, or because it's cloudy in the case of biophysical indicators. But at some point, you get some values. And in this case, so for a 2-month period, there are 1, 2, 3, 4, 5, 6, 7 values during this period for this parcel, and then for the other ones, the other one. So that's for the API service. Then if you want to directly read the markers in the Arrow IPC files, it's also possible. And it is described here where to find these files inside the system. It's also explained and described in the sum. And now we're going to do a demonstration. So I will hit the presentation. Yeah.
During just a few minutes when you prepare the demonstration, I would like to add something because there has been some confusion brought in the chat. I would like to clarify something. So there is no interpolation and no gap filling, no averaging when we monitor the practices. Practices monitoring is based on each acquisition date. The interpolation and the gap filling are done for the markers that will be used for the classification. And the reason of that is rather simple, is this because the classification algorithm embedded in Send4Cap has been specifically designed to run over large areas. So we do not process tile by tile, we built the classification model over a big region. And so within this big region, it is mandatory to get time series with the same dates on every pixel within the region, and so across the tiles. And so this is why we are doing these steps for the classification. So this allows running over a large area, and this is absolutely needed when you want to scale up to national processing. But for the practices monitoring, this does not take place. So there is absolutely nothing which is iron or smooth by average. We do practice monitoring, just to clarify that. And then I will I give you the floor again, Philippe, and we will come back to the questions after the demo.
Okay, thank you for the clarification. So now we're gonna connect to a web interface of a system. So in fact, this is the machine that was used for the demonstration in Lithuania in 2020. I guess you are used to the system, so you can see that there are different tabs. And so to launch, we're gonna just show you how to launch the Markers database processor. And it is in the same way as the other processors, in fact. And there are two ways to do that. So first, via the dashboard. And so you can see the different processors, and the last one is the Markers database processor. In the dashboard, you can schedule jobs. So it can be in the past, then it will be triggered directly, or if it's in the future, it will be triggered at this date. But you can not change. So when you define the date, the scheduled date, it will use all the data before this date. You cannot choose the input data. So it's, and how you do that, you have to add a new job. You can see that there were already a job added and executed. You have to give a name. You have to select your site, the season. And then there are different types of, in fact, of scheduling, you can say. The first one is just if you want to do one time the process, and you have to define the date. The second one is a cycle. So you have to define the first date, and then it is launched again after X days. And then the last option is to do a repetition. So you have to define the first runtime, and then it will be run every, for example, 15th of the month. So that's it. And yeah, when you are doing the continuous monitoring, it's useful for you to repeat the launch of this processor. So for example, for every 2 weeks, and it will, when you are using the dashboard, so it's doing the first extraction, and then if you do 2 weeks later, you do again the extraction, it will only extract the markers for the data of the 2 last weeks. So it will not do the total, all the extraction again. Then the second way to do it is via the custom jobs tab. You can see also the different processor. And here, so there are no advanced parameter, but what you can do is to select the data on which you want to extract the markers. So for example, if you want to extract markers only in June, you just define the period here. You filter the data. You just have to select the data that are filtered. There are a lot of coherence and amplitude for 1 month. And when you submit it, it will do the extraction. Compared to the dashboard, also, when you use the custom job tab, it will do the whole extraction each time, but you can select the input data. And so it can be faster. You can also filter by tile if you want to only process some tiles. So this is how to launch the Markers database processor via the web interface. And it's the same kind of procedures than the other processors. Then we're going to see some example on how to access the markers. So here I just have some requests already defined, but these are the same that were shown in the slides. So if you go on your browser, you will get the JSON response. You have, of course, to define the IP address of your machine and the port, and then the different information. And you can see the different marker names that it was also shown in the slides. And then if you want to get values, you have to define a bit more information, and you can see here the answer. But what's interesting is, of course, to import, so to include these requests in scripts. And I'm just going to show you a simple example in R, where you
Philip, it's just a request from the chat. Can you please make the font larger?
The police larger, or
the font, the text, because it's hard to read.
The text. Yeah. Okay. Even for here it was small. Yeah. So I will just show you a bit bigger. But it was a request that was also shown in the slides. So this is the response, and the other one here, with the values for these two parcels. Now in R, okay, I don't know if I can zoom somewhere. Zoom in. Yes, zoom in a bit more. Still a bit more. Okay, so here it's using just a library which enables to import markers or import information through API, and then some library to deal with the JSON format. You can see that I just defined the information of the IP address, the short name of the site that I want to extract the markers, the year, and so on here. And when I run it, I will a bit describe the script still. So here you get the markers names. Then here this part is doing the extraction of the values, and then the last part plot the results in a graph. And so maybe we can first launch the first part until the marker names. And you can see here that you get the list of markers corresponding to the site that are defined. And then if you continue the script, it will plot the results inside a plot for these two parcels. And here I selected, I don't know if you see it, but the NDVI and the LAI. So I just wanted to show you two small scenarios using this script, but it's a very simple one, just to have some idea visually. But here is, in fact, the last product that was delivered to the Lithuanian paying agency, the product of the crop type. And you can see the legend here. Maybe it's too small, but the different colors are corresponding to the parcels that are assessed as conform, so classified and conform. Classified and non-conform are in red, and the not classified parcels are in the color. And in fact, the examples that I showed you here is the example of this parcel and this parcel. So a grassland parcel and a spring cereal. And so you just need to check the new ID, which is here. And if you enter it in the code, it was already done. You can see that. So this temporal profile is the temporal profile of the grassland, you can see that the NDVI values are during all the year quite high. And you can see some events here, a mowing or a grazing event, and here also. And on the other way, the spring cereal has a profile with very low NDVI values at the beginning of the season, then an increase when the crop is growing, and then the harvest. And it looks like there's also a catch crop, which is put in place after the harvest of the crop. Another example that I wanted to show you is an example where you so for example, here there's a parcel which was assessed as not conform, and when you check the prediction of the model, in fact it's declared a winter cereal, but what the classification is predicted is a spring cereal. And what I wanted to do to confirm or not this first assessment is compare the temporal profile of this parcel of winter cereal with a spring cereal, which is just close to it. And when you do that, so you just need to retrieve the new ID of these parcels. And when you launch it again, you will see that the temporal profiles are quite or almost identical between these two parcels. So it is a sign that maybe, like the classification was predicted, the winter cereal is maybe a spring cereal instead. So this is visually what you can do with the markers, but of course you can do some automatic comparison of profiles between different parcels, between different crop types. So it's up to you to use in any way the markers database. And this is it for the demonstration of the markers database.
Thank you, Philippe. There have been many questions again.
Yeah, it's a bit small also.
Philippe, there was a question. Can you switch back to RStudio if you didn't already close it? So the LAI is the upper one. You can see the label on the right.
It's on top. Yeah. So for the often the NDVI is saturated at some point. It was especially the case for the first example, while the LI still increases. You can see it here. Or for example, for the grassland parcel, the difference between NDVI and LI is quite. You see, the two profiles are different, so it's why the LAI has an added value. I mean, but LAI is on the top and NDVI on the bottom.
Okay, thank you. So there has been a question at the end from David about the cloud management. That's true that for the moment so the signal is aggregated at the parcel level, and we do not provide by parcel an indicator that specific pixels or a given amount of pixels are affected by cloud. So that could be
cool.
That could be a good features to add. This is a nice suggestion, and we take note. A more general question: there have been some users are asking if we can provide some scripts as to start. So the scripts that you are showing here as examples can be shared. I think yes.
Yeah.
I don't see any.
Yeah, no problem.
Problem to share that. For sure.
But these are really simple scripts. You can, but yeah, I can share it. Yeah.
Okay.
Should we also have an example of reading the markers file directly? So it's easy to do that in R, but
I think
maybe
I
someone
didn't
wants to see
prepare
it.
one.
I think we can provide for all the cases. There have been many questions asking for directly accessing the arrow.
So the plotting is the harder part, not reading the files.
Yeah. Okay. So this is that. Maybe we are a bit behind the schedule, but I would like still to have the open question, and really this is an open question also for the consortium. This is something that we already discussed, but we never came to a conclusion. How would it be possible to add additional markers in the database in terms of work, and also then from the user's perspective, how make a selection which is relevant for many users. So maybe someone from the consortium, Cosmin or Laurentiu, you can comment on the possibility to add markers. Well, basically, this is Sen4CAP is open source, and so anyone who wants to modify a bit the way the values are extracted by parcel and to compute new ones, it is possible to do that. I don't know us as a consortium, because we are at the end of the project, how possible it would be, or at least to give some guideline on how to do that. Maybe this is the way to move. Cosmin.
I think. Yeah.
Oh, Philippe.
No, I think some guidelines could be shared for the extraction of the markers. And anyway, the data are there. So the biophysical indicators at pixel level, the Sentinel-2 preprocessed data, the Sentinel-1 coherence and amplitude. So you can run also your own script on the machine directly. And the different products are, listed in a good way with different informations in the name and so on. So you can also use your own scripts. But it was just a comment.
Yeah.
Yeah, so it's about the amount of integration that you want to have with the rest of the system. So if it's fine for you to write a script that looks up the products in the database and opens them, computes some statistics and saves the results, that's pretty easy. If you want to see the results of this script in the user web interface, in the website, for example, or if you want to set up a schedule for running this automatically together with the other processors, then that's a bit harder, because you have to do the full integration with the system. You have to write a bit of code to